Hi, Algebra 2. This is a video of the answers for the homework for 11-7, where we're actually graphing sine and cosine graphs. So the basic thing to remember, the difference between the sine and the cosine graph. So in question 1, I have y equals the sine of x. That's the light blue graph that's right here. So that graph goes through the origin 0, 0. And the critical values for that are 0, 1, 0, -1, 0. So those are all the values from 0 to 2 pi. So basically, there's one full cycle or one wave between the point 0 and 2 pi. So you can see right here at 0, it's 0. Right here at 2 pi, it's 0 again. And in between, this is pi right here at 0, so this is pi. So basically it's 0, it's pi over 2, it's pi, it's 3 pi over 2 is -1, and then at 2 pi it's 0. And then the same wave goes in the opposite direction with the points negative pi over 2, negative pi, -3 pi over 2, and -2 pi. So that's the blue graph. Now, if I put a number in front of that, 3 sine of x, basically I'm going to take those critical values right here, but I'm going to multiply them each by 3. So it's going to have a height or an amplitude of 3. So the 0 obviously stays 0. 1 times 3 is 3, 0 stays 0, -1 times 3 is -3, and 0 stays 0. So that's the green graph. So this stays at 0. Pi over 2, though, it does not have a height of 1, it has a height of 3. And my critical values change to 0, 3, 0, -3, and 0. But again, that full wave, that full cycle is happening between 0 and 2 pi. What happens when I put a negative in front of there? I'm basically reflecting it over the x-axis. So the blue graph is the regular sine, y equals sine of x. The yellow is y equals negative sine of x. So you can see 0 stays 0, but 1 becomes -1. And here, -1 becomes +1. So it's like flipped around. It's a reflection. So my critical values, the 0 stays 0, 1 becomes -1, 0 stays 0, -1 becomes +1, and 0 stays 0. And that full cycle, that full wave, still occurs between 0 and 2 pi. So that's the sine graph. Cosine graph is this yellow graph right here. So cosine graph does not go through the origin. The cosine, the critical values are 1, 0, -1, 0, and 1. It's still completing one cycle between 0 and 2 pi. So 0 is 1, pi over 2 is 0, pi is -1, 3 pi over 2 is 0, and 2 pi is 1. So that's this yellow graph, my critical values for cosine. These are important because if you know the critical values for the basic sine and the basic cosine graph, then you'll be able to graph anything if we change the amplitude, if we change the frequency, the period, we do vertical shifts. So those are all things that we're going to work on in this unit. So my critical values for cosine are 1, 0, -1, 0, and 1, and that occurs between 0 and 2 pi. That's the yellow graph. If I have a 4 in front of it, then I'm changing the height of the graph. So that's the green graph that's right here. So all I do is take my critical values and multiply them by 4, and my critical values are 4, 0, -4, 0, and 4, and those all occur between 0 and 2 pi. If I have a -3, then I'm multiplying these critical values up here by -3. 1 times -3 is -3. 0 times -3 stays 0. -1 times -3 is +3. 0 times -3 stays 0. 1 times -3 is -3. So these are my critical values between 0 and 2 pi. So 0 is -3, 2 pi is -3. Pi is 3, 3 pi over 2 is 0, and pi over 2 is 0, and that is the blue graph. Okay? If we look on the next page, I want to know the range of this function y equals 7 sine of x. Y equals sine of x, the range is between -1 and 1. So that is the parent function. That's the range for the regular y equals sine of x. If I have a 7 here, my amplitude is 7, I'm going to multiply that range by 7. So the range for this function would be between -7 and 7. So the 7 in front changes the height, it changes the range, changes the y values. 4 wants to know what is the period of y equals cosine of x. So the basic sine and cosine graphs repeat every 2 pi units. So that is the period. That's one cycle occurs between 0 and 2 pi, as we saw in those graphs we did. Which of the following equations describes this graph shown below? So right away, I know that I have to decide whether it's sine or cosine, because I got both choices here. This is a cosine graph because it's not going through the origin 0, 0. Now, a normal cosine graph, though, goes through 1. So this one has been reflected. So this one has to have a negative. So it starts at a minimum. So the number in front is going to be negative. And you can see normally it goes through 1. This is going through -3. So the graph is y equals -3 cosine of x. Number 6, which of the following equations represents this curve? This is going through the origin, so this is a sine graph, and it has a height of 4, but it has not been reflected, so it is just going to be y equals 4 sine of x. If at pi over 2, it wasn't up here at 4, but it was down here at -4, and the curve was going the opposite way, then that would be y equals -4 sine of x. 7 wants to know which of the following lines would not intersect the graph of y equals 6 sine of x. So this graph has an amplitude of 6. So remember the normal range is between -1 and 1. Well, this would have a range of between -6 and 6. If I was actually to graph this, I drew like a little fake graph down here. This line right here, y equals 9, is a horizontal line. It would not go through the graph. I'm looking for which of these lines would not intersect this graph. X equals 8 and x equals 3 are both vertical lines, so they would intersect the graph because this graph, even though I've only drawn part of it, this graph continues, this wave continues. Y equals -4 is down here. Remember, my range is -6, so that would intersect the graph. So that's why the answer is choice 4. Okay, and those were the answers for the homework.